Good evening and welcome to the APAC edition of the vBrownbag podcast. I'm Alistair Cook, and as the APAC edition is having a nice little segue into the wonderful world of Hyper-V, we're going to carry on looking at the Microsoft certification, the 409 exam around Hyper-V. I'm really pleased that I don't have to teach this because I need to learn this. And I'm joined by Pravesh, who's going to be covering some material for us. Just a quick bit of background info. You probably see this on a lot of videos. vBrownbag, you can follow us on Twitter using the @vBrownbag. If you'd rather consume content in Spanish, then we have the Latin American edition, and we also have an EMEA edition. And at the moment, the US and EMEA edition are covering the Cisco certified CCNA qualifications. Brett very happily has lined us up, but it's me, Alistair, hosting today, and of course the main content is all coming through from Pravesh. So I'm going to hand straight over to Pravesh and let him take over and teach us all about this Hyper-V stuff.
Oops, the wrong screen. Thanks, Alistair. Just let me hit the first button that became available, and that stuffed up a few things. Oops.
We have the typical vBrownbag stutter as we switch presenters.
Of course. Can you see my screen now?
Yes, we have your initial slide up.
Cool. Thanks, Alistair. Hello, everyone. Welcome to this overview session of Microsoft Exam 7409, which is called Server Virtualization with Windows Servers Hyper-V and System Center. Bit of a mouthful, isn't it? My name is Pravesh Khanna. I'm based in Melbourne, Australia. I'm a technology enthusiast and an active blogger. During my day job, I work as a System Center specialist for one of Australia's leading bank on technologies like Microsoft Hyper-V, System Center Configuration Manager, System Center Virtual Machine Manager, and VMware ESXi. You can follow me on my blog at it-ninja.com.au or on Twitter at PraveshK2012. With the introduction out of the way, let's jump straight into today's topic, Microsoft Exam 7409 overview. My presentation tonight will contain a mixture of slides, demo, and some real-world examples from my professional experiences. So this particular exam, which targets the Microsoft Hyper-V technology, it is based on Windows Server 2012 R2, and it is targeted towards the IT professionals. Like most of the Microsoft exams, this is a multiple choice, hotspots and scenario-based exam. And most of the skills measured on a very, very high level are configuring Hyper-V, configure and manage virtual machine and high availability, implement a server virtualization infrastructure, and monitor and maintain a server virtualization infrastructure. Now, I will take you with a quick overview on Hyper-V, and the reason being that in the exam, you might actually experience questions where they will talk about this is what you have at the moment, and this is what you're trying to do, what are the benefits. So it always pays to know about those kind of technology, not only the current one, but at least on a very high level, what used to happen in the previous version of Hyper-V. The Hyper-V is Microsoft virtualization platform. Yes, we know that. It's a type 1 hypervisor. Now, a lot of people ask, what is a type 1 hypervisor? Now, type 1 hypervisor is one which actually runs directly on the hardware platform. It does not require another operating system to load before a hypervisor is loaded. A lot of the older versions of Microsoft Virtual Center or virtual servers, that's how it was. It was type 2 hypervisor. It required Windows to be running on top of before the hypervisor could come up. Hyper-V doesn't require that. It itself sits on top of hardware and then runs operating system on top of it. It got released with Windows Server 2008, and the current version, which is running right now in production, is Windows Server 2012 R2. Windows Server 2016 with lots of improvement with Hyper-V is currently in technical preview, but obviously it's not available to general public yet, and it's not production ready. There is a free version of Hyper-V. It's a non-GUI version, so for typical people who know Windows with start menus and all that, none of that is available. It's a typical non-graphic based, text-based operating system, but it's available for free. Remember that if you are running a Windows Server 2012 R2 with standard edition, you only licensed to carry 2 guest OSs, 2 virtual machines that can run at a given time. You cannot run more than 2. So most of the people, at least what I know of, is Windows Server 2012 R2 with Data Center Edition, which entitles you to run unlimited number of VMs. Here is the history of Hyper-V, which we are going to start with Windows Server 2008. When Hyper-V got first released in 2008, it was added as a post-RTM update. So when 2008 was released, Hyper-V wasn't there. They released it after shipping it. It was wouldn't say it would be very much enterprise class ready back then. You could only have maximum of 4 virtual CPUs and only up to 64 gig of virtual RAM per virtual machine. And a given VHD to attach to a virtual machine could only be 2 terabyte. It used to support a feature called quick migration, which is not very similar to what VMware does with vMotion. It required the if VMs could have been moved between the cluster nodes, but for that to happen, the VM actually required to be paused and restarted. Not very enterprise class ready, was it? It did support snapshots. So it was basically a point in time image of the virtual machine, and it did support pass-through disks. Now this pass-through disk was basically you have a physical LUN, which was attached to the virtual machine. And this was to overcome the 2 terabyte VHD limit for per VM. That's how it was. Rolling forward, we come with Windows 2008 R2. Now this was in many way, it was very much an improvement over the initial release of Windows Server 2008 Hyper-V. It supported live migration, which means instead of waiting few minutes, or could be up to a minute or 2, depending on the size of the virtual RAM in 2008, you can actually live migrate a VM from one cluster node to the other within few milliseconds. The cluster shared volumes got introduced. Now this was a feature of Windows rather than just Hyper-V alone, which means multiple nodes within a cluster could access the same LUN at the same time. And this was done by mounting a LUN on top of a drive letter. So instead of each host looking at their D drive XYZ, they were looking at D volume 1, D volume 2, D volume 3, and all hosts would have access to that volume 1, volume 2, volume 3 mount points. That means they can all access the same disk at the same time. You were able to add SCSI storage on the fly. You did not require the VM to be powered off. Hyper-V supported jumbo frames and virtual machine queues, which was like a feature which required a certain type of network card. If they supported it, you could actually enable jumbo frames, which means bigger size chunks could be sent on the network card, which means quicker migrations and better performance for your live migrations and your traffic. NIC teaming. It wasn't supported by Windows, but it was supported if your hardware vendor, your NIC vendor actually supported that. You could have done NIC teaming. Funny enough, before 2008 R2, this wasn't supported. It had SLAT support. Now, SLAT support is basically, it's a feature of your CPU, which actually reduces the hypervisor overhead. So what happens is your CPU actually maintains a table which actually maps the virtual memory against the physical blocks on the RAM. That's how it worked. And this was a very much a performance improvement on when it comes to Hyper-V. Processor compatibility mode was introduced in this particular version. And what that means is if you have a two host with similar kind of CPUs, not exactly the same. So one with a Xeon processor, one is with an i7 processor. Before this version, you would not be able to migrate machines across the two nodes. Now you can actually mask those underlying features of the CPUs, and you can actually migrate things across. Remote FX, another very important feature. Remote FX was basically having your physical servers or your host GPU assigned to virtual machines, so you can have a better performance in terms of video processing. You can actually have high graphic requirements within a virtual machines. Now you can actually do that. You can have dynamic memory for virtual machines. Now, dynamic memory for virtual machines means you can actually assign, instead of assigning a fixed level of VRAM to a virtual machine, you could now set up a lower limit, a high limit, and a startup limit. I'll show you quickly what exactly I mean in this case. So in my lab, which I got here, I have got a few virtual machines running in this environment. And if I go to the settings for these ones, if you see, this one is actually using dynamic memory. So what happens in this scenario, I've assigned it 2 gig worth of startup RAM. This is how it will see it when the machine first starts up. If there is not enough requirement, after the startup, the amount of RAM that is consumed by this virtual machine will drop down to 1 gig, but can go up to 4 gig at a memory buffer of 20%. What that means, if there is a requirement by the virtual machine for whatever reason, because of the application demand or by the operating system demand, the virtual machine, if requires, can draw more RAM, and the hypervisor would transparently add that virtual RAM to the virtual machine to actually meet up the demand. If that demand dies down, for example, you were running some processing and that actually memory requirement goes up, and now that processing is over, you do not require that much RAM, you can drop to a minimum of 1 gig. And that would be, for a modern operating system, that is perfectly okay. Older operating system like your Windows 7 backwards, not suggested to do that, but 2008 R2, 2012 R2, 2012, or a lot of new versions of Linux, it is fine. They can do it. So it's one of the features within Hyper-V which got introduced in 2008 R2. Moving to Windows 2012, this was another big leap over the 2008 R2 features. They increased the number of vCPUs to 64, and you can have a maximum of 1 terabyte RAM per VM. You can have NUMA nodes now within Hyper-V. Now, what is a NUMA node? In a very, very basic and the way I initially explained it to myself many, many years ago when I first started looking after virtualization was, in a physical hardware, there are different, so you have a hardware with multiple CPUs and multiple RAM blocks. What happens is, for the best performance, it's always advisable to actually assign the closest memory bank for a given CPU to its virtual machine. This provides the best performance for the virtual machines. Now, given that virtualization is all about making maximum use of physical resources on a given hardware, we can always borrow memory off not the closest memory bank on a hardware. And that's on a very, very basic level. I mean, you can go very deep into this NUMA example, but this is on a very, very simplified version of what NUMA nodes are. So this NUMA node was supported in 2012. You can have maximum VHDX size of 64 terabyte, huge compared to what it was initially. You can have up to 64 nodes in a Hyper-V cluster. So instead of the previous version that we had, 64 is a huge, huge improvement. You can also perform now storage migration, which VMware calls storage vMotion. They had it for years. Now, finally, Windows 2012 started supporting it. We also had something called Hyper-V Replica. Now, again, it is there now in 2012. However, it was fixed to 5 minutes. You can only have a 5-minute replication. So what Hyper-V Replica was, you have a virtual machine running in your production data center, for example, and you have a replica of that running in your disaster recovery data center, a DR site. And the replication difference between the two virtual machines would be fixed at 5 minutes. So at a given time, if you lose your production virtual machine, you tend to lose your 5 minutes worth of processing or the data sitting inside that virtual machine if there was some transaction that went through. So it wasn't recommended back then to have it for really highly critical kind of virtual machines where you need every less than 5 minutes worth of data. So it wasn't advisable back then. You could do shared nothing live migration, so you could actually have the live migration happening over just, all you need to have is network connectivity across the two hosts. They need not to be part of the same cluster. They need not to be part of even the domain. And you could have just shared, migrated VM from one to the other. SMB3 got supported in 2012. That was introduced as a part of the operating system. SMB3 protocol in itself brought a lot of security, a lot of features, huge improvement in performance, and many, many more features. That got introduced in Server 2012. You had the ability to virtualize your fiber channel cards. So in other words, if you have a virtual machine or many virtual machines and you have a physical fiber channel card on the machine, now you can actually assign them virtually over to the virtual machine instead of just relying on your VHD files. So that was another big improvement in 2012. Moving to the current version of Hyper-V, this was a great improvement in the history of Hyper-V. In many, many sense, this actually brought a real enterprise class performance and features to Hyper-V coming up from 2012 R2. We had something called shared VHDX files. Now what that means, let me demonstrate it to you quickly. A shared VHDX file is basically your, you can have guest clustering based on a shared VHDX file. Now for a shared VHDX file to be supported, you need to have, if I go back to my slides again, which is there, you can, which is a shared VHDX file, you need to have a clustered shared volume or an SMB share. You cannot do it on a local disk. That is one of the requirements. So in my environment, I do not have a LUN or a CSV as such. But if I try to add a new hard drive to this and I try to create something with dynamically expanding disk, and it's sitting on my D drive. Nothing special. I'll just name it demo. I'll give it a size, 40 gig. Fair enough. I can add it, no issues. However, if I go to the advanced features, I have an option to go enable virtual hard disk sharing. What this allows you to have is one or more, or two or more virtual machines sharing the same hard disk at the same time, kind of mimicking what you have in a real clustered environment with iSCSI or fiber channel LANs. Similar kind of feature, but for that to happen, if I try to do it here, it will bomb out. You know, can anyone tell me why? As I said before, the storage where the virtual machine hard disk is located, it does not support virtual hard disk sharing. So yeah, I'm just running it on my D drive, which is a local attached disk. It is not supported. Had I done this thing on a iSCSI or a fiber channel LAN, this would have worked like a piece of cake. Okay, the other big feature that we had was compressed live migration traffic. So what happens if you perform the live migration before it was all going, if it was a 40 gig file that you're transferring over the wire, it will go as a 40 gig. Whereas now with 2012 R2, you have the option to compress that live migration traffic, and that will actually perform the migration a lot quicker. So if I go and check the Hyper-V settings on my machine, you can have enable incoming, and one of the advanced feature is you can have compression, which is on by default. On this particular Hyper-V, you can change between TCP/IP, so uncompressed or compressed, or just go via SMB, so using RDMA. So that is one of the features that got introduced in 2012, R2. You can have the generation 2 virtual machines, which supported the new UEFI BIOS instead of the traditional BIOS that we used to have. We had 2012 R2 brought the storage quality of service, so you can actually now limit how much storage IOPS a virtual machine can have. That way you can actually, if there is a noisy VM causing disruption to your storage because it's trying to consume too much, you can actually limit it. You can have automatic VM activation. Now this is a very, very good feature. What essentially this means, if you have Windows VMs, you don't really require KMS or anything like that to get those VMs activated from Microsoft, because now you can, as long as your host is activated, it will automatically activate the guest operating system. The other big improvement is Hyper-V Replica. Now, remember in 2012, the original version of 2012, we only were fixed to 5 minutes of replication interval. With 2012 R2, we can go, we have 2 or 3 different versions of replica. One is your 5 minutes, obviously, which was already there. You can go all the way up to 15 minutes, or you can bring it down to 30 seconds. So now you have less chances of losing data, or less data at risk, where if the replication fails or if you lose the VM, you only have 30 seconds to worry about it. And the other important thing is they added a tertiary replica site. So instead of having just 2 replicas, now you can have a 3rd replica site. And the other important thing is the snapshots, they got renamed to be checkpoints. So what we used to have as snapshots, they're now called checkpoints as 2012 R2, which is the current version. Now, if you remember, initially I quickly brushed through this idea of generation 2 virtual machines. Well, that borrows a question. There must be a generation 1 virtual machine. Now, people ask me, what is a generation 1 virtual machine? Now, these are the older type virtual machines that was supported on 2012 Hyper-V or before. So 2008, 2008 R2 or 2012. Those were called generation 1. They used to have the earlier BIOS-based architecture, and the guest operating system that got supported here were Windows 7, XP 2000, Linux, a lot of older versions of Linux. The server operating system were 2008 R2, 2008, Windows 2003, Windows 2000, but the host operating system you require was 2012 or below. Let me just quickly show you what a generation 1 virtual machine looks like and what are the main differences just in a live form. This is my generation 1 demo PC1, which is running Windows 7. Very typical operating system. But if you look at the device manager on this particular one, you see here there's a lot of older kind of hardware, floppy disks, IDE disks, PS2 mice. Who needs that these days with Windows 10 and Windows 2012 and things like that on the, nowadays? Why would we need this kind of old hardware? So what we have here is, let me quickly sign into my newer operating system, which is a 2012. It's a generation 2 virtual machine. And if I go to the device manager here, and when it loads, have a look. It's much, much more cleaner. It doesn't have all those older kind of PS2 things and doesn't have the older kind of storage controllers. It is a lot cleaner compared to what we had in the other, which is demo PC1. So comparing 2 side by side, look how cleaner this looks. So on the left, we have a generation 1 virtual machine. On the right, we have a generation 2 virtual machine. Those are the main differences. Again, you require older kind of operating system for generation 1. A Generation 2 virtual machine, again, like I said, it requires Windows 8.1 or Server 2012 R2 and above. It supports the newer kind of EFI-based architecture. It supports secure boot. So now you actually can encrypt your hard drive. So it actually prevents it from, malicious people getting into it and trying to break into your virtual machines just by getting the VHDX files. The synthetic drivers that boot, the VM bus, the boot from SCSI virtual hard disk. So instead of using an IDE disk, which was a requirement from the Generation 1 virtual machines on the left, as you can see, IDE disk. Now we have all SCSI stuff. There is no emulated or legacy devices, and they boot 20% faster. This is all the stats from Microsoft. On an average, they boot about 20% faster, and the guest operating system installation is about reduced by 50%. So much better performance when it comes to Generation 1 and Generation 2 virtual machine. The difference between the two. Other topic that I touched before was dynamic virtual machine, which I was just demoed. Actually, I did it before ahead of time. Sorry about that, but here is what I was talking about before. The dynamic memory allocation controls the amount of physical memory that is allocated to the virtual machine. It lets you define the initial, minimum, and a maximum memory amount. The hypervisor adds and removes the memory as needed. So you do not need to worry about it yourself. It's all done behind the scene for you. It only works with Windows and Linux operating system that supports the ability to hot add RAM. So that is a very important point. Do not try this with the older kind of operating system. So your Windows 2000, Windows XP, Windows 7, not really supported. But the newer operating systems, your Windows 2012 R2 and the newer versions of Linux, feel free, go for it. It cannot hot remove the RAM. It can hot add. So if you want to drop down, so initially you assigned it a 4 gig RAM at maximum, and now you want to drop it down. Well, not really. You can't do that. And VM must be VM must be rebooted if you want to reduce the amount of memory given to it. The other important thing which the Windows 2012 brought with it was the support for VHDX files. Now, VHDX files are basically your virtual hard disk file formats. The original ones used to be called VHD files. That was what got introduced with Windows Server 2008 and 2008 R2. The limitation for these ones was it only supported up to 2 terabyte size and only had older kind of operating systems, 2008, 2008 R2, 8R2, and Windows 7, and all the other the versions of operating system before that. It can be converted to VHDX file, but and there are a lot of free tools available. One of the biggest advantage of VHDX files compared to the legacy format is the storage capacity. Before Server 2012, the Hyper-V virtual hard disk had a 2 terabyte limit. Now VHDX files have a limit of 64 terabyte. So it's massive improvement. And they're not only limited to just the capacity. They were designed to work with the modern operating system and hardware and have 4 kilobyte logical sector size that improves the performance compared to VHD files. They also provide protections against file corruptions related to power failure. So if your virtual machine or your host suddenly dies, actually there is a continuous keeping track of the updates in the metadata for these VHDX files, and that prevents that accidental loss of data. The one other point that I want to mention is if you are going to convert your VHD files to VHDX, make sure you are running it on Windows Server 2012 or above, so 2012 or 2012 R2. It cannot be done on 2008 or 2008 R2. Very important point. Another something, again, something that I demoed before, shared VHDX files. It allows for guest clustering and requires the VHDX hard disk file format. It requires the underlying storage to be SMB, SAN, and iSCSI. And it requires Windows 2012 R2 hypervisor. It cannot be done anything before that. So if I had, in this place, if I had a 2012 server or 2008 R2 server, not supported. It can't be done. So that is a very important point. Another very important topic when we're touching these disks is differencing disks. What is a differencing disk? Well, imagine in a scenario where you have a large deployment of VDIs. Now, in many scenarios, these are non-persistent, so people in a help desk environment log on to their VDI, a virtual desktop environment. They don't, as long as they get a standard environment, they don't have to save any data onto your C drive, or the user the admins do not require them to have that. What essentially they can have is a master disk, and all the changes to that and that is the one that gets allocated to all the VDIs. If user requires them to be any information to be changed on those PCs, that get written to a second disk. So your base operating system image always remains the same unless you update it. But all the user information or any changes written to that disk are not written to the master disk, they are written to a differencing disk. They have two different, the two terminologies that we use with regards to these differencing disks is parent disk and child disks. So what you have a single disk which contains all your operating system and your key configuration with regards to that, and any changes to that get written to the child disk. And the differencing disk data can keep writing to it as long as there's enough space on the physical disk underlying. So under your LUN, as long as there's space on your LUN, you can actually keep writing to the child disk. Or you have a limit reached to the size of your child disk. They can expand dynamically as the data is written to it. You don't need to manage that part of it, and can grow as large as the maximum size allocated for the parent disk. So if you have a parent disk assigned to 60 gig, you can, provided you have sufficient storage available on your underlying storage, on your LUNs or your iSCSI LUNs or your fiber channel LUNs, your differencing child disk can go up to 60 gig in this scenario. So very important thing to remember. Another important point that I touched before was checkpoints. Got introduced with the initial release of Windows 2008 Hyper-V, but they were renamed to they were called snapshots in Windows 2012 and before, got renamed to checkpoint in 2012 R2. What it does is actually creates a point-in-time capture of RAM, CPU, system state, and disk contents. It does degrade the performance while checkpoint is written. So that's another important point. If you are performing a checkpoint on a given VM, obviously because you're writing data to the disk and actually at the same time, the hypervisor is trying to maintain the current operation of the virtual machine as well as trying to keep a snapshot of it, there is a bit of performance degradation. The way it is done is there is a file called a VHD file is created for every VHDX file, and the VHDX files become read-only for the time. So all the data is being written to that a VHD file. How do you perform a checkpoint? The two ways, and this is again a very important way for this particular exam. PowerShell. Make sure you know both ways of using Hyper-V. Of course, you need to know the GUI version of everything. So in this example, if you want to checkpoint at this given machine, I can just right-click or navigate on the menu on the side and just hit the checkpoint. Either way, this will create a point shot in time for this particular virtual machine. Now I can go and muck around, I can patch with it, I can deploy an application if I want to, if I don't trust it too much, that what would this particular application do or the configuration change I'm about to perform. I can always do this and I can manage it from here. I can always delete these checkpoints. I can always manage it either using the GUI or always can do it from the checkpoint name. So using the PowerShell module. So in this example, I have this virtual machine which I call as WinServer 001, which I have just created the checkpoint for. I can manage the same thing with PowerShell. And if I go and run this particular command, boom, oh, doesn't work. Why is that? Any guesses? Well, the simple reason is I haven't imported the PowerShell module and I haven't got it installed on this one. And oversight on my part, so apologies for that, but a simple reason being I haven't installed the PowerShell module for this particular, for Hyper-V on this particular machine, and I haven't imported it within PowerShell. But very important one to remember that you can manage checkpoints and most of the things within Hyper-V using PowerShell. This is a very, very important topic when it comes to your exam. A checkpoint can be exported using the export VM snapshot commandlet within PowerShell, and the resulting VHDX files can be used to create a clone of the original VM. So there is no direct support of cloning of virtual machines within Hyper-V as opposed to what you have within an ESXi environment, but this is the way of doing that within Hyper-V. Another important topic that I want to touch here are Hyper-V virtual switches. Now, Hyper-V virtual switches are the way for virtual machine to connect to the real world. In my lab environment, I can access that using the Hyper-V switch manager, virtual switch manager. I have created 3 different switches here. If you notice, they're called vSwitch external, vSwitch internal, vSwitch private. What are these 3? Why did I create these 3 different ones? Let's start with external, easiest one to understand. This is the external type of virtual switch, which must be connected to do a physical adapter on your host. It allows communication between your physical network and the management operating system and the virtual machines. So all 3 of them, your machines outside on the other network, as well as your guest operating system and your host operating system can all talk on this, but if they are connected to this if any virtual machine is connected to this particular virtual switch. You can use the same private IP address range for adapter as an external virtual switch that you're using on the physical network it is attached to. So if you're in your external network, if you're using 10.x.x.x network, you can do the same here. No reason that you can't do it. Moving on to the next type, which is virtual switch internal here. It's called an internal switch type of virtual switch. It is a similar one to the private switch, which I will come to a bit later on. It allows the virtual machine to only talk to the host operating system. You cannot talk to anything else. So any virtual machines connected to the internal type of switch can only talk to other virtual machines connected to the switch, the same switch, as well as the host operating system. That's it. They cannot talk to anything else. If you have a virtual machine which is connected to a private type of virtual switch, they can only talk to other virtual machines connected to this private network. So if you are setting up a private lab kind of environment, which have to be very isolated, not connected to anything else, this is your way to do it. It's not connected to anything, or depending on your real requirement, you can go either private or internal network. In those kind of, if you want to have it connected to your external network as well, then you need to go to your external type of switch. And what the other thing to remember here, if you have a network adapter, which in this case, I'll show you the 2 types of network adapters I have available here. And this is a very important part from my professional experience out in the industry. I had 2 types of network adapters attached to it, a host management and a Hyper-V. So one is dedicated for all my host management, all my remote desktop connections, my file copy, things like that, and a Hyper-V which is dedicated to all the virtual machine traffic. Now, if you notice in the drop down, I can only see Realtek PCI GBE Family Controller 2 and Controller 1. Where is this host management Hyper-V? Well, it goes by the device name, not by the friendly name, which I have put on the left-hand side, if you can see. Another very important thing. And the most crucial thing, which I'm about to share now, the network adapter that you have bound to this particular virtual switch actually does not become available to the host operating system unless you check this box. The host operating system cannot use this this Ethernet adapter unless this box is checked. So in this case, even though it is visible here, if I go and perform an IP config, oops, the IP addresses associated to this particular Hyper-V adapter would not be available. Again, very important point. So coming back to the slides again, those are your 3 types of virtual switches that are supported in Hyper-V environment. This brings me to the next topic with regards to the particular exam. A lot of people come to me and ask, what should we do and how should we prepare for and how should we get familiar with Hyper-V? I know we all know about ESXi, but Hyper-V, how do we play around? Number 1 tip is build yourself a practice lab. Very important. Do it on your home, do it at your work, wherever you have flexibility to do so. You do not need a big hardware requirement for it. Myself, if I go back to my lab and show it to you, doesn't have high specs. So if I go and check things, it only is running with 12 gig of RAM and a 4-core CPU, and 2 Ethernet cards. These days, this is very much at par of what you can have. Not much requirement when it comes to those kind of things. You can download an eval, I think it's a 60 or 120 days eval of Windows Server 2012 from the below URL. Highly, highly recommended. Go through this 2012 R2 Hyper-V features. This is the URL that I have pointed you towards. Another one that I can share you with is this early expert study group, which was created back a few years ago, but it still is a lot valid when it comes to this particular exam. They take you through a lot of scenarios and hands-on labs. Got lots of links on how do you do this, how do you do that within Hyper-V. So kind of a lot of real-world examples from the experts within Microsoft community. The other stuff is TechNet. TechNet is very big resource when it comes to anything to do with Microsoft, and not to mention virtualization in itself. This is the particular link that I personally used to actually go through and know more about every aspects within Hyper-V 2012 R2, and can highly, highly recommend that to everyone out there in the community. Another one that you want to try is actually get yourself more familiar with the actual exam. There is a Pearson MindHub official exam from Microsoft. It is available on for anyone to purchase. It's not that expensive, but it's worth investing. I think it's about $30 or $60 from my memory. It has the best part about this particular practice exam is it has detailed answers and references to if you have selected a particular question and you have answered it in a certain way. If your answer is wrong, why is it wrong? And it's the real answers, not someone's guesses. So very important, guys. I know a lot of people go through these unauthorized study material, and the answers on all of them, like the reasoning for given for a particular answer, it's all over the place. Do not believe them. Trust me, take the word from me. Always rely on the certified stuff. Always rely on the Microsoft official stuff. You know it's coming from the real experts. Please take that advice. You'll make your life a lot easier that way. It will provide you, an instant score report. So it will also tell you which part of the particular technology you are weak in or you need more work on, and which of them are your strong points. So you know where exactly to focus your efforts to. Obviously, Microsoft Virtual Academy, a huge library of videos and Microsoft presentations across various forums. Highly recommended. Go through it. If you haven't signed up, just look for mva.microsoft.com and make yourself familiar. Just do a quick search on Hyper-V. All you need to do is that, and it will give you hundreds and hundreds of videos from all levels of Hyper-V topics, from very minimal to very advanced level. They're all sorted by, level 1, level 2, level 3, and based on your own familiarity with the actual topic, you can go through them. And another very important point, the MVP community. People like Aidan Finn and Thomas Muir out there. I personally, follow them. Great guys. I have put their blogs on here. Go and search for them. I'll click, and provided it opens, based on my internet connection. Oh, and there we go. Finally opens up. aidanfinn.com. Great guy. He's like, a gun when it comes to Hyper-V. Highly recommended, man. Go for it. Read through his blogs. He goes through a lot of examples, lots of hands-on examples, and within his blog. Highly recommended. And same for Thomas Muir. Both of them very highly recommended. So that brings us to the end of my presentation.
Excellent, and if I unmute, I can thank you for that. No, I hear silence at your end. Alrighty. That was all good. I'll just hit the stop recording button.